Hello friends. Now we are going to discuss about our next topic, particle in rigid box. Particle in rigid box. This is the application of our previous lecture topic, that is Schrodinger time independent wave equation related to the 6 mark. Particle in rigid box. Consider a particle. Consider a particle of mass m moving with velocity v in a rigid box. Rigid in the sense potential is infinite from the boundary of this box. Potential is infinite. Outside the box, potential is infinite. Here, potential is zero. Means particle is capable to move freely. Potential is zero. Free particle. So this one is x is equal to 0 and this one is equal to x is equal to L, means width of the box. This is the box. The width of the box is L. Particle in rigid box. This is rigid box. Rigid in the sense boundary is rigid. Particle cannot travel or particle cannot move from a rigid box to the outside area. So this is rigid box. This is width of box L. Width of box is L, and potential is 0 in the box. Potential is infinite outside the box. Now let us start with this Schrodinger time independent wave equation. Del square psi plus twice m h cross square E minus V psi is equal to 0. This is Schrodinger time independent wave equation, and from this wave equation, from this time independent wave equation, we have to find wave function of this particle or energy of the particle present in this rigid box. So condition is what? Condition is, now we have to find potential or total energy or wave function inside the rigid box, and inside the rigid box potential is 0, so V is 0. Equation is twice m h cross square E psi is equal to 0. Potential is 0 inside the box. Now let us assume k square is equal to twice me upon h cross square. Let us assume k square is equal to twice me upon h cross square. Del square psi plus k square psi is equal to 0. For example, this one is equation number 1, equation number 2 and equation number 3. Now this is second order linear differential equation, and we have to find the general solution of this equation. Del square psi plus k square psi is equal to 0. Now according to variable separable method, the general solution of this wave equation is psi is equal to a sin kx plus b cos kx. A and b are constants and can be found out by using or by applying boundary conditions. K is propagation constant, and this one is sine function, cos function, and we have to find now actual function of this system. Now we have to find these constants a and b by applying boundary condition. What is boundary condition? Boundary condition first. At x is equal to 0, at x is equal to 0, psi is equal to 0, because at x is equal to 0 particle at rest, then particle at rest means wave function is 0, because wave function is produces when particle moves with particular velocity v. So at x is equal to 0, particle is at rest, therefore wave function 0, and at x is equal to L also wave function 0. So these are the two boundary conditions. Second boundary condition is at x is equal to L, again psi is equal to 0. First boundary condition, first, at x is equal to 0, psi is equal to 0. Apply to this equation psi 0, a sin kx plus x is equal to 0, b cos k 0, sin k 0, this term is 0, plus cos 0 1, so b is equal to 0. We get b is equal to 0. So what is wave equation now, or what is the wave function? Wave function equation is psi is equal to, this b is 0, so equation is a sin kx, equation number 4. Now second boundary condition, at x is equal to L, psi is equal to 0. So at x is equal to L, psi is equal to 0, that is a sin k L. Now a amplitude and this sin k L is equal to 0. Amplitude never be 0. When amplitude is 0, if we apply or if we take amplitude is 0, then wave function is 0 at all positions and at all times. So this we cannot take a is equal to 0. We cannot take a is equal to 0. So sin kl is equal to 0 or kl is equal to n pi. Or we can write k is equal to n pi by L. So what is equation? What is using this k in this equation, we will get psi is equal to a sin value of k n pi by L x. This is the wave function of particle in rigid box. This is the wave function of particle in rigid box moving with velocity v. X is the position in the box, n is the energy level, simple on ground state energy level, first excited state energy level, second excited state, third excited, like this. N is equal to 1 2 3 like this. So this one is the wave function. And next, what is energy? Energy, see here, k is equal to n pi by L, and again here is k square is equal to twice m e upon h cross square. So compare these two equations. For example, this equation is 5. Compare equation 2 and 5. K square n square pi square L square is equal to twice me upon eh cross square. We can write from this equation, we can write E is equal to n square pi square h cross square is equal to twice m L square. This is the total energy of the particle inside a rigid box. The problem will be asked related to the 4 marks on this equation. E, total energy of the particle, n square pi square h cross square upon 2 m L square. M is the mass of particle, L is the width of box, n is the energy at what energy particle is present. Means, for example, n is equal to 1 ground state energy, n is equal to 2 first excited state energy, and n is equal to 3 second excited state energy. So wave function is equal to a sin n pi by Lx, and E is equal to n square pi square up h cross square upon 2 ml square. Thank you.